Hello everyone, this is Aditya and I welcome everybody to 3D Studies. And today we are going to have an interesting topic, periodic table, means periodic classification. And this chapter comprises of your class 11th chemistry. And today in this video we will be covering full history of periodic classification. We will be knowing history of periodic classification or the journey towards our modern periodic table. How we are came to know our modern periodic table. So let's begin. So for understanding periodic classification, the first term, what is periodic table? So let me tell you. Periodic table. So what is periodic table? We all know there are all the elements. We know probably all the elements. So for organizing the known elements, for organizing well-known elements with their appropriate physical properties in groups and columns. Okay? Now, the history that covers periodic classification started with a great scientist, that is number one. We'll be talking about Lavoisier classification. Now, Lavoisier discovered that every well-known elements needs to be classified in two ways. Like these are your elements, and he used to classify all the elements in two subgroups. What were the two subgroups? Let me tell you. The first was your well-known metals, and secondly your non-metals. So he classified all the elements as metals and non-metals. He says every element is distributed into two subparts, that is your metals or non-metals. Now here's what is. After that, the limitations occur for your Lavoisier classification. And the limitation occur, you are talking about metals as well as non-metals. What about your metallites? So yeah, he doesn't give the single space for metalloids. Doesn't give a space for metalloids. So that was a huge drawback about a Lavoisier classification. Moving ahead, I hope this is clear. Moving ahead to the second scientist and a well-known scientist, that is your Proud's trait or classification. Now what Proud says? Proud says that every element is made up of your hydrogen atom. He says that we all know all elements are made up of your hydrogen atoms. And he also says that for asking about the atomic weight of any element XYZ would be equals to m multiplied by atomic weight of hydrogen atom. Now you would ask me what is here? Yours m. M is the number of atoms, number of hydrogen atom. He says for taking out or for knowing atomic weight of any such element, you are required to know the number of hydrogen atom present in that particular element, and multiplied by its atomic weight of hydrogen atom, you will get your atomic weight. Now here's your limitations are. What are the limitations? You probably knowing. The first is your simple. Is every element made up of your hydrogen atom? Not at all. So all elements were not made up of hydrogen atoms. So this listed in the drawback of your Proud's classification. Now let's move ahead. The third classification that we are going to put our eye is Dobrynia's trait. Okay, it's Dobrynia trait. Okay. So what he says let's group the elements in such a way that in three groups. Group elements in three groups so that in a manner or in such a way so that the middle element should be the arithmetic mean of your other two elements. What he says group an element in such a way that group up element in three columns and in such a manner so that middle element जो उनका बीच का element हो और जो other sides के element हो तो जो उसका बीच का element हो वो उन दोनों elements का जो उनके side में है उनका arithmetic mean हो. How and what are the elements that came in Dobrynia's traits that were your trait number 1, your Li, Na and K. Lithium, sodium and potassium. This is your trait number 1. Trait number 2 goes as Cr. Trait number 3 is your Cl, Vai, and trait number 4 is your Sete. Okay, so these are the four traits discovered by Dobrynia's. He says this first trait is known your alkali metals. Second trait is your alkaline earth metal. Third trait is your halogens. And fourth trait is your others or other elements left over. So it says like lithium we know Z is equals to 3. Potassium we know Z is equals to 19. Sodium we know Z is equals to 11. So the differences between these two is 8. Adding on 8 in 3 going to give you 11. Adding on 8 to the 11 you're going to get is 19. Okay. So this was a Dobrynia's traits. Now what is the limitation over Dobrynia's trait was at that time 56 elements were well known. But all the elements you can see over here in this particular table, not at all. So all the elements were not classified in this particular trait, limitation number 1. And limitation number 2, he says that the arithmetic mean needs to be in the order. But not more elements were seen at this are taking the properties as similar to this particular trait. So these were the limitations for Dobrynia's trait. Now we will be moving ahead and understand the other OR traits. We'll be talking about fourth number, Newland's law of octave. Newland's law of octave says that here Newland says group the element in such a way that the element needs to be in an increasing order of their atomic weight as well as every eighth element should have the similar property as the first one. So Newland's law of octave says group an element in such an order of their increasing order of their atomic weight that every eighth element, हर एक eighth element should be similar and should have the similar property as compared to its first element. Now let's take an example. You are not required to learn all the elements in the Newland's law of octaves. What is requirement is to understand Like I take it X, Y, Z, A, B, C, D. Okay. Okay. So look at the example. I took an example of some elements. Now what it says it is the element organized in an increasing order of their atomic weight, right? And also every eighth element. Look at every eighth element. 1, 2, 3, 4, 5, 6, 7, 8. Now here M will have the similar properties as the first element, that is your X. Okay. Now after M we have N. Let's count it. 1, 2, 3, 4, 5, 6, 7. Your U. Now U will have the similar properties to your N. So this is the group or the octave table of your Newton's law. Now let's talk about the limitation. Now limitations is, okay, the limitation first is this particular table is only applicable till Z is equals to 20. And they were the elements well known 56. So again, this is a huge drawback of your Newland. Secondly is, not every such element will show the similar properties as 8th element to the first element. So these were the huge drawbacks of your Newland's law of octave. Now let's move ahead and understand the fifth law, that is your Lothar-Meyer law. Okay, now the fifth is Lothar-Meyer curve. Now according to Lothar-Meyer curve, what he says? Now Lothar-Meyer curve says that the curve made between atomic weight as well as to the atomic volume. Now what happened? Let us see Lothar-Meyer curve. It is somewhat, first thing is requirement is, we know mass is equals to density upon volume. And here if we wanted to know atomic volume, what would be the formula? That will be density upon atomic mass or weight. Okay? This formula needs to be remembered by us. Now, this particular x-axis shows your atomic mass. This y-axis shows your atomic volume. Now, the curve goes for Lothar-Meyer's curve is somewhat. So this is the curve of Lothar-Meyer curve. What this says, what are the observations that we get? The first observation, jitne bhi elements are on the peak. Every elements are on the peak are you're called as alkali metals, like your lithium, potassium, sodium, and so on. So jitne bhi peak mein elements are, and that is going to be listed in your alkali metals. The elements which are coming in the middle or in the bottom of the curve are known your transition elements, also known as or well known as D block elements. So transition elements are coming where? At the bottom of the curve. Now there were two more observations are ascending order of the curve. Now here I can write it. You can see it very carefully. Ascending order of curve shows your ascending order of the curve shows your halogens, and your descending order curve shows your descending order is somewhat like that, shows your alkaline earth metals. Halogens like your Br, bromium, fluorine, iodine, like that, okay? So the curve of Lothar-Meyer curve shows ascending order as halogens, descending order as alkaline earth metals, transition element at the bottom, and alkali metals at the peak. Limitations for Lothar-Meyer curve. Now the limitation for Lothar-Meyer curve is, first thing, in the year when Lothar-Meyer curve was produced, The similar year, your Mendeleev published his periodic table. So what happened is, as compared to Lothar Mayer's curve and your periodic table of Mendeleev's periodic table, it was seen that Lothar Meyer curves was insufficient as comparison to the Mendeleev's periodic table. And also, first and most appropriate limitation is that Lothar Meyer curve is unsystematic. It is not systematic and a person can easily not able to, keep and recall all that element that this is in peak, this is in bottom, this is in ascending order, this is in descending order. So for that such reason, it was a huge drawback for Lothar curves. Now let's talk about, the sixth part and in the same year who developed his periodic table and gave a huge, or you can say plays a huge role in giving the base in the modern periodic table. Now the fifth part is your Mendeleev's periodic table. Mendeleev's periodic table first assigned its periodic table as, he says, this is my structure of periodic table. He says every horizontal rows are your periods and there are 7 horizontal rows. He says in my periodic table I'm going to list it horizontal rows called as periods and they are numbered as 7. Talking about vertical columns, they are listed as your groups and there are how many vertical columns? You all probably know that is 8. So yeah, it was a structure of Mendeleev's periodic table. Now, what are the observations for Mendeleev's periodic table? It was found that at that time, Mendeleev's periodic table was the most systematic table ever seen. What I can write is, it was the most systematic table. It was the most systematic table ever seen. Secondly is he predicted the future element. How he arranged the element, look at the thing, like A, B, and he left it some part, then A, B, C, D, E, and left it some part. So in his periodic table, he gave a vacant spaces in the periodic table. And you know why he gave the vacant spaces in the periodic table? Because he know the future element which is gonna be discovered will be fit in this particular area. And what he just tell about the prediction, he predicted future elements and the future elements or the predicted elements were like first, second, third, fourth. The fourth prediction he gave was, the first prediction I'm going to write is upside. Prediction number 1 was Eka aluminium. Now Eka is a Sanskrit word which means one. Means aluminium, the element which is going to come, उससे पहले aluminium having this particular properties, right? जो element उसने predict किया, उससे पहले aluminium is gonna be there, and also that particular element will be identified by Eka aluminium and its atomic masses, densities, and every physical properties he already predicted. Now Eka aluminium, and yes, this Eka aluminium element nowadays known your gallium. I hope you understand. Now the second is your Eka silicon. That is your germanium. Now the third is your, and fourth. Third is your boron, which was now discovered as scandium. Fourth is Eka manganese, which is Tr element. So these are the 4 elements discovered or predicted by Mendeleev. And we all know nowadays these elements with these names. So a huge and respectful prediction was done by Mendeleev. Also, moreover, you can write about the, you can say, observation of Mendeleev's periodic table was At that time, like gold, beryllium, you can say it lithium, beryllium, boron, carbon, nitrogen. So these are the elements we know. So at that time, what happened is everybody known that barium have somewhat 11 point something atomic mass. Like everybody known that barium ka itna hi mass hoga. And boron has 10, lithium has 7. Okay. Now Mendeleev says you all are known are wrong atomic masses of these elements like beryllium, your gold. So everybody asked that why you are saying just thing. So Mendeleev replied that see, as beryllium stays at the between of lithium and boron, and if lithium has your 7 atomic mass and boron has your 10 atomic mass, so it is very clear from your eye that beryllium needs to be greater than 7. Any number needs to be, or any number which is atomic mass of beryllium needs to be greater than 7 and smaller than 10. And in the future, exact thing happened. Beryllium had atomic mass of greater than 7 and smaller than 10. So a huge prediction was done by Mendeleev. Now let's talk about demerits of Mendeleev's periodic table. Mendeleev's periodic table. So what are the demerits? Demerits or drawback for Mendeleev's periodic table. The first was hydrogen atom. Hydrogen atom was not given a single space in the Mendeleev's periodic table, and also this particular atom shows both the properties of metals as well as your non-metals. So this was the reasons behind your demerit for hydrogen atom. Second is your isotopes. Isotopes were not given a position in its table. Third was your drawback was like PT and your gold AU have the similar property but arranged in different groups. And from this only it comes like Cu and Ag, which have different properties but arranged in similar groups. Also, the fifth is many elements were not placed according to their increasing atomic masses. Examples could be, you can write to in the comment below, okay? And examples could be your cobalt, nickel. So there is a huge difference between the atomic masses of their both, but still they are kept in the same groups. So this was a simple drawback for limitations of Mendeleev's periodic table. Now let's talk about Mosley's periodic law. Okay, let's talk about Mosley periodic law. One of the interesting, I can say, topic. Now Mosley periodic law says that here Mosley does an experiment, I can say. He took a metal of any, there were elements like metals and non-metals. He took a metal element and does a electron bombardment on it. What he did is, he took a metal element or a metal sheet of any element who is a metal, and he did a electron bombardment on it. What he saw as a result? He saw X-rays are produced of your valence, your frequency. Now frequencies of X-ray are produced. So he gave a formula. From this is under root of your frequency is equals to the number of that particular matter. the number of that particular matter. Okay? Now, from this particular, I can say formula, moreover, what he made it, under root of frequency is equals to your z, and here what does he did it, I can say he gave the formula as square root of your frequency is directly proportional to the number of that particular, and you can say number of that particular matter. Now, siding of this particular directly proportional sign, I'm gonna give two constant over here, and mostly gave a two constant over here as az minus bz. Okay, or it can be written as za minus zb. So this is the formula he gave. Here a comma b are some constants, v is your frequency, and z is your atomic number of that matter. Atomic number of that matter. Okay? Now also, you can see it very carefully, under root of v is equals to az minus bz is in the form of y is equals to mx minus c. Now here, m is your slope, c is your intercept. And yes, you can clearly see intercept is of your minus, so we can have a graph for this particular definition. That is the graph goes as, this is the x-axis, which is a slope, and yeah, the slope is over here is z. This is the y-axis, gonna give you under root frequency, and yes, the slope is here is a negative. So I'm gonna get is a negative slope over here, making an angle with the x-axis, which is your atomic mass of the matter, which is theta. Tan theta is equals to your slope. So this was explained well by your Mosley periodic law. Okay, so I hope this is clear to you. We have discussed all over history of periodic classification. Now what was we discussed is, let me give you a revision. Firstly, we discussed is Lavoisier classification. Secondly, we discussed is Proud's classification. Okay. Third, we discussed is Doverillier's law or trait. Fourth, we discussed is Newland's law of octaves. And fifthly, we discussed is Mendeleev's periodic table. Sixthly, we discussed Mosley law of periodic law. Yeah. Also, we discussed Lothar Mayer's curve. So these six, I can say, the particular history about periodic classification and the history behind reaching the eighth topic, that is your modern periodic table. So this was a base for modern periodic table. I hope you enjoyed the session and understand everything in brief and conceptual clarity. Now I want from you that I'll be teaching you modern periodic classifications in upcoming videos. And if you like my content, do subscribe by hitting the like button and share this video to your friend. If you have doubts, you can do write in the comment below. I'll be clearing it, okay? And thank you for watching and stay tuned.